Hello everyone, let's talk about factoring. Now the method that I'm going to show you is probably my most favorite method because it works with most factoring. Yes, there are shortcuts. Yes, there are formulas you can memorize. But what if you're not good at memorizing? What if you don't see the shortcuts? Let me show you a way that will be foolproof. It will work with most of your factoring. Now I have a little product sum finder calculator on the right hand side of my screen, and I will use that and show you how I use it, and I'll also provide the link in the video description in case you would like to use it too. Okay, and as I'm looking at it, I can see that there's a mobile version of this. Pretty neat. All right, now what we are going to do is called the AC method, or sometimes called the product sum method. The reason we're calling it the AC method more often is because a usual quadratic is written as ax squared plus b, oh, that was an awful b, let's try that one again, bx plus c. All right. What is ABC? Well, those are some numbers. So a means some number in front of x squared, b is some number in front of x, and c is our constant. It's going to be just a regular number without any variables. Now, I think you can see in the first problem, right underneath it, I have several minuses. Well, that just means that the b and the c are negative numbers. That's all. Okay. Now, I start these off always by labeling, so I don't make a mistake. So that's A, that's B, that's C. So what we're first going to look at is the product, A times C. Well, the number in front of x squared is that invisible 1 that always shows up and hangs out, but we can't see it. So we have 1, and C is negative 70. So A times C is negative 70. Next, I want to write down what my B is. B is negative 3. All right. Now, once I've done that, I have to think of two numbers. Two numbers that multiply to form negative 70 and add up to form negative 3. Now, if this is something that you're not good at, use this awesome product finder. In the product, we're going to write negative 70. In the sum, negative 3. I'm going to click Find Product Sum. Look at that. It tells us what it is. It's negative 10 and positive 7. You could have thought of that right away. That would have been awesome. But not everyone has that skill, and that's fine. Another reason why it's called the AC method is because we keep the A and the C terms. I totally made that up, but that's a good rule. All right, so we have the A term, which is x squared, and we keep the C term, which is negative 70. Instead of the B term, instead of that negative 3, I'm going to use the two numbers that we found, negative 10x and positive 7x. I added x's in the middle because we need, to form an x in the middle. All right, perfect. Next, we're going to go into factoring by grouping. I'm going to split my expression in half, and I'm going to take out a GCF. Oh no, I totally forgot to talk about GCF before starting this problem. Luckily, that was okay. Now, GCF is your greatest common factor, and as a rule, you should always look for one. The reason I skipped it by accident and didn't say it out loud is because our x squared had a 1 in front of it. Most of the time, not all of it, but most of the time, that means there's not going to be a greatest common factor. But my bad for not checking. I will do that for the next problems. Okay. On the left-hand side, the greatest common factor between x squared minus 10x is x. So let's factor it out. And that's through division. The right-hand pair, the 7x minus 70, see how it starts with a plus? I'm going to write down a plus. All right. The GCF between 7x and 70 is 7. Let's divide it out. 7x divided by 7 is x. Negative 70 divided by 7 is 10. And now we have this beautiful thing happening. We see 2x minus 10. I could actually just write it out once. And then I am going to take the outside numbers, the x and the plus 7, and I am going to smush them into a single parenthesis. And it's factored. Yes, this one has a shortcut. If you see, the two numbers we came up with ended up being the two numbers in parentheses. But what if you forgot that shortcut? Right? Am I right? I'm right. Let's go to this next one. Okay, not like 13. Let's think about it. Is there a greatest common factor between 3k squared minus 14k minus 5? Nope, none of that. So let's go ahead and label A, B, C. I'm going to write down A, C, and B. All right. 8 times C, so 3 times negative 5, is negative 15. B is negative 14. So we want to think of two numbers that multiply and get us negative 15, but when we add them, we get negative 14. Again, this might be something you're familiar with, but maybe it's not. So let's check it out. In this product sum finder, we could actually plug in the 3, the 14, and the 5. So let's try that out and see how that goes. Don't forget to put in the minus for the negative. Okay, so we have negative 15 and positive 1. And you know what? We're going to do the exact same method as we did on the last problem. So let's try that out. The A term stays the same. This is my made-up rule, but it actually works. And so does the C. Next, I'm going to take those two numbers we found, and I'm going to put them in. Now, if you had written in your notes, or as you were doing this problem, the 1 first and the minus 15 second, you're going to have the same answer as me. It's just the work is going to look a little different, but the answer will be the same. Okay, let's get started. Split it in the middle. I like making a nice squiggly line. The GCF of the left-hand side will be 3k. Let's divide it out. K minus 5. This next right pair starts with a plus, so I'm going to write a plus. Okay, now this one's tricky. I don't really see a GCF with 1k and minus 5. 1 is prime, 5 is prime. So what's the only thing both of them divide by? Well, it's a tiny, tiny number. It's 1. Fantastic. We ended up with 2k minus 5s, which means we did it right. And we have two outside numbers, 3k plus 1. Right now, I feel like writing 3k plus 1 in this parenthesis and k minus 5 in this one. Does it matter the order that you put them in? No, as long as one parenthesis has k minus 5 and the other one has 3k plus 1. If the k minus 5 one is on the left and the k plus 1 is on the right, it doesn't matter. Again, as long as they're both there. Okay, onwards and upwards, number 15. Okay, let's see if there's a GCF. Do you see a greatest common factor in this trinomial? Sweet, I hope you do. It's 8. Not just 8, it's 8x. All right, let's factor this out. So we're left with x squared minus 2x plus 1. Fantastic. Let's label A, B, C. Okay, our AC, the number in front of x squared is 1. So 1 times 1 is 1. B is negative 2. So two numbers that multiply to form positive 1, but when we add them, we get negative 2. You might know this off the top of your head. It's -1, and -1. If you already know the pattern to this problem, to this type of problem, that's awesome. But if you don't, let's do the AC method. So 8x is still hanging out up front. That's just going to hang out until we're done with the problem. And then I'm going to keep my A term. I'm going to keep my C term. And I'm going to put those two, whoops, I was going to color code that. Those two numbers, the -1x and -1x in here. Squiggly line, let's group. All right, this pair, x squared minus 1x, I can factor out an x, and I'm left with x minus 1. Now see how that right-hand pair starts with a negative? That means I start with a negative. That's just always how it's going to be. All right, well, what do 1x and 1 have in common? Well, they have a 1. Since I'm actually factoring out a -1, let's think about this. -1x divided by -1 is a positive x. -1 divided by positive 1 is -1. And check it out. We have two x minus 1s, which means we did this correctly. All right, 8x is still hanging out there. We already factored it out. There's nothing we can do with it. We have x minus 1 and another x minus 1. Sweet. You could actually simplify this just a little bit and rewrite it as x minus 1 squared. Would it be wrong if you left it with two x minus 1s? No, not really. But it is more concise if you make it x minus 1 squared. Let me do some more color coding. Boop. All right. Wow, these problems take a long time, huh? Yeah. So if you need to show your work, this is how you can always show your work. Right? Otherwise, there's lots of great other calculators that actually factor for you. Wolfram Alpha is one of them. It's great. Oh no, I had a problem right here for number 17. Where'd it go? Where'd you go, problem? Where'd you go? There it is. There it is. Okay, well, it's already been a 12-minute video, so I'm going to pick and choose the ones I want to do. I think 17 is a great one to do, so let's do it. I want to show you that this method is possible even when there's a binomial. Again, there's a trick to this guy. This is a difference of two squares, so if you know what it is, you're awesome. But if you don't, you know what, you're awesome too. We're just going to take this a slower way. Okay, now we're missing the middle term, so I'm actually going to rewrite this as x squared plus 0x, meaning the x's don't exist, minus 49. All right. Now I have my A, my B, my C. Same process. AC, 1 times -49 is -49, and our B term is 0. So what we're thinking of this time is, what two numbers we multiply to get -49 and add up to get to 0? So let's see. -49 into our product, 0 into our sum. It's 7 and -7. Right, maybe you knew that right away, maybe you didn't. Doesn't matter. All right, our A and our C are staying, so x squared and a minus 49. But in the middle, we are going to write minus 7x and plus 7x. And we're back to grouping. Let's do it. On the left-hand side, we have a GCF of x. Let's factor it out. And on the right-hand side, we start with a plus, so I start with a plus, and the GCF is 7. And we're left with the following answer. X plus 7, I'm going to rewrite that plus sign because that's ugly, plus 7, and x minus 7. So the trick here, if you're interested, is that when you see two numbers, or two terms, I guess, with a subtraction sign in the middle, we want to see, well, are they perfect squares? Is that possible? Well, x squared is a perfect square because it's squared. It kind of gives that away, right? Then we have 49. 49 is 7 squared. So if you happen to memorize it, when that happens, we can kind of square root it and have an x plus 7, x minus 7. Okay, I think that's what I wanted to do on this worksheet. Although the other ones are great, and I did enjoy making my own little answer key, I don't want to make this video too overwhelming because I have done another video about factoring before, so go for it and check it out if you'd like. Otherwise, here are 4 problems that I hope will help you, and yeah, have a wonderful rest of whatever day it is for you. Bye!